Hello guys, my name is Professor Jatin Verma. Talking about myself, I have done my engineering in mechanical. After that, I have done my masters in robotics. I am presently pursuing my PhD. I also promote GATE. I have 5 years of teaching experience in engineering colleges all across Mumbai and in coaching institutes also. So today we are going to understand a subject of engineering drawing, which is into your second semester of first year of engineering. In this we'll be understanding some basics of it, and then we'll be going into detailing in the further parts. Okay, so what now we are going to understand is the chapter of projection of points. If we are understanding the location of points, then we'll be able to understand what is projection of lines. Okay, so I hope you are knowing about the coordinate system. If I am talking about the coordinate system, okay, this is my 4 quadrants. The first quadrant, the second one over here, the third quadrant is over here, and this is my 4th quadrant. Now, till now I was saying this was my x-axis, this was my y-axis. Now I'll say this is my HP. HP is what? HP is horizontal plane. Okay, so my y-axis becomes VP. VP is vertical plane. So what I'll say is I'll locate my points. Suppose I'm having a point A over here. This is in the first quadrant. Okay, I am having the another point over here. This is in the second quadrant. I have one more point over here, and the last point in my 4th quadrant. Now what is happening is I have to remember one sequence over here, and that sequence is observer, object, and then the plane. Okay, so what is happening is, suppose I'm over here. Okay, I'm the observer. This point A is my object, and this VP is my screen or the plane. So when I am looking at the object, so sequence is what? Observer, object, and plane. So I'll get the image of it on my VP. Okay, so what is happening is, suppose if I am going from here, okay, so what I'll be getting over here is this will be A dash. Why it will be A dash? Because it is the front view. Front view is always denoted by dash terms, and top view without dash terms. Yes. So this, if I am looking from the top now, so what will be my sequence? Observer, object, and then the plane. So what will be over here? I'll be getting the image of A point, and that will be A. The image will be A. So this will be A dash because it is the front view. This will be A because it is the top view of it. Similarly, when I am talking about point B is in second quadrant. Yes. So what will be happening when I am looking at the object? Again, this becomes my front view. So this will be B dash. Correct. If I am looking from the top, again observer, object, and the plane. So this will become what? This will become B. Similarly, this is my third. So if I am going for this becomes my front view. So this will be C dash. And if I am talking about another point of C, that is a top view. See, now I have to, although I am saying it as the front view, but I am looking from the base, because my sequence cannot change. So it will be what? Observer, object, and then the plane. So this point will become what? C. Okay. Similarly, if I am talking about D point, so it will be, this will be D dash because it is the front view, observer, object, and then the plane. And then if I am going to the top, it will be again observer, object, and then the plane. So it will be D. Okay. So further what we'll be doing is we'll be going for the further quadrants and the points in different quadrants. Okay. Suppose if I am taking point B over here, if this is my point B, so this becomes my what? This becomes my B dash because this is the front view. This becomes my B because this is my top view. My rule is what? My rule is I have to rotate my, this becomes my HP because I am talking about the second quadrant. Yes, and this becomes my VP. My rule is I have to rotate my HP in clockwise direction by 90 degrees. I cannot change the rule. So what will happen? This B will now be shifted over here because this will be rotated. Okay, always my B will be rotating because it is on HP. HP is always rotating. Okay. Similarly, if this is my third quadrant, if I am taking my third point over here, okay, so this becomes C dash because this is the front view, and this becomes my point C. Again, my rule is what? My rule is I have to rotate my, see, this is my third quadrant. Okay, so third quadrant, what is happening? Again, I have to rotate my HP in clockwise direction by 90 degrees. So again, this point C over here will be rotated, and this will be point C. So what is happening in second quadrant is my front view is above xy. This is my xy. So front view is above xy. Top view is again rotated above. So it is also above xy. So front view and top view both are above xy. If I am talking about C point is in third quadrant. The front view of it is below xy, but the top view is above xy. Okay. Now let us understand what will happen if I am talking about the fourth point, which is in the fourth quadrant. Okay, so this becomes my front view. So the front view is below xy, and this is my top view. So this is my D point. But rule is again what? Rule is this is my VP, this is my HP. HP is rotating by 90 degrees in clockwise direction. So this will be again going downwards. So if this is going down, what we'll be having is I'll be having D, that is D is denoting what? D is denoting my top view. So front view as well as my top view is below x-axis. So I have got four conclusions over here. The first conclusion, if my point is in first quadrant, what will happen? The front view above xy, the top view will be rotated and thereby the top view below xy. If the point is in second quadrant, the front view above xy, the top view again above xy. If I am talking about the third quadrant front view below xy and the top view above xy. If I am talking about the fourth quadrant, the front view below xy and the top view again below xy. So these are the four conclusions of points when they are located in different quadrants. Now we are going to understand projection of lines. In this chapter, the main part is master diagram. If you are understanding master diagram, understand the conclusion of every sum that you are going to attempt is a master diagram. So if you are understanding master diagram, you can attempt any sum of projection of lines. I will be using some basics of projection of points. I hope you remember the projection of points, and then I will be going for projection of lines. Let us understand. Suppose I am having one problem. The problem is I am having one line AB. Okay, so I am having one line AB. The true length of it is given as suppose 70 mm. Okay. Now what is given is it is having some inclination. Okay, the line is inclined. So what is inclined? The true length is inclined. So true length ka inclination, when I am talking about front view, I will be denoting it as theta. For instance, I am taking it as 30 degrees. Okay. Now one more thing, if I am taking the true length inclination, but now with respect to VP, if I am talking, so it will be, let us assume it to be 45 degrees. So what is there is I am having one line, the true length of it is how much? 70 mm, and I am having two inclinations of it. With respect to front view, it is how much? 30. With respect to top view, it is 45 degrees. Okay, so let us draw that line. For that, first of all, I have to draw my xy. So that becomes my xy line. Now, what is given is, in this line AB, what is happening? I have been given the location of point A. Point A is above the xy, above the HP by 10 mm. So above the HP, I am talking about HPC related is always dash terms. So it will be front view. So this is 10 mm. Now, it is given that point A is in front of VP. See, understand. If it is above HP and front of VP, so I am talking about, yes, the point is in first quadrant. So my rule is what? The point will rotate and go downwards. Why? The rule was what? Rotate your HP by clockwise in 90 degrees. Okay, so it will be going downwards. So this will be A dash, which will be representing the front view, and it is given 20 mm in front of VP. So 20 mm in front, so that point will be going down. Okay, but that point will be denoting what? That point will be denoting your top view. So dash, sorry, without dash. Okay, this will be with dash because I am talking about front view. This will be without dash because I am talking about top view. Okay, I have been given true length as 70. Understand, true length is never changing. If suppose the length of this chalk is, for instance, 10 centimeter. Okay, if I am tilting it now, 10, again 10. So true length always remains same. So it never changes. Similarly, so what will happen? if I am drawing this part, so this is my what? This is my front view. Okay, so front view से related true length, I will be writing that as true length. So true length is 70. You've been wondering ki what is this inclination? This inclination, I told you, this inclination will be what? Theta, and that will be how much? That will be 30 degrees. Now, same when I am talking about the top view, again the true length will remain same. The true length will be 70 only. Okay, and this inclination will be what? This inclination will be, yes, it will be 5, and that will be 45 degrees because it is mentioned over here. Now, I have to name this point. Understand, the front view of the true length will always be what? A dash, and this point will be B1 dash. Understand, front view is always with dash and top view is without dash. So this point I am marking, this is my true length but related with top view. Yes, so it is, I am marking this point as B2. It will be always AB2, and over here it will be always A dash B1 dash. Now what is happening is, what I am drawing is, I am drawing one line which is parallel to your XY. Okay, I am passing through B1 dash. Similarly, from here also I am drawing one line, okay, which is parallel to XY and passing through B2. I will be calling out this line as locus of B. Over here I will be naming this line as locus of B dash. Now, locus is what? Locus is the line on which B dash is going to lie. Where? I don't know. But on this line it is going to lie somewhere. Okay, similarly for B, this is the locus. So on this line there will be my B point somewhere located. Okay, what next? See, understand, what I will be doing is, this point I will be projecting it down. Okay, this was B1 dash. Okay, so I am projecting this point downward. I am taking it down perpendicular and till front of A. See, this was B1 dash. If I am projecting it down, this will be B1. Now what I am doing is, I am rotating it. So this is meeting it at this point. So this point is nothing but your point B. Okay, now understand, this part from A till B1 is called as PL. PL is nothing but your planned length. Okay, so what you have to do is, if you are joining this line, this is called as, yes, this is called as the top view of it. So this becomes my top view. Okay, and the associated angle becomes beta. Okay, similarly what I'll be doing is, I'll be projecting this B2 upwards till where? In front of A dash. So this was B2, so this will become what? This will be, yes, this will be B2 dash, because now I am talking in terms of front view. Okay, now what you can do is, you can rotate this and make it cut locus of B dash. So this point will be what? This point will be B dash. Now when you are joining this point, okay, so this is your what? This becomes your front view, and the associated angle becomes alpha. Okay, you will realize one thing, that this B dash and this B are in one same line, and because of that only, see, understand, this B1 dash and B1 same line, B2 dash, B2 same line, similarly B1 dash and B has to be on the same line, and finally this is your master diagram. Understand, conclusion of any sum based on projection of lines will be this master diagram only. Okay, I hope this was clear. This was all about projection of lines. I hope you liked my demo lecture on engineering drawing. For any doubts and queries, please do contact on my WhatsApp number. I'll be ready to help you. And for any sessions and personal coaching, please feel free to contact. And please do like, share and subscribe. Thank you. Thanks a lot.